How a Bitzer condensing unit works in cold room. Discover how Bitzer condensing units maintain precise cold room temperatures through a continuous refrigeration cycle. This guide explains each component and process step. Refrigeration cycle overview. Understanding the continuous heat transfer process in cold room systems. Step 1. Compressor draws in low-pressure refrigerant vapor from the evaporator, compressing it into high-pressure hot gas. Step 2. Hot gas enters the condenser coil where fans blow ambient air, rejecting heat and cooling the refrigerant. Step 3. Refrigerant condenses into liquid form and flows to the liquid receiver for temporary storage. Step 4. Liquid passes through filter dryer to remove moisture, then through sight glass for condition monitoring. Step 5. Expansion valve creates pressure drop, converting liquid to cold low-pressure mixture entering evaporator. Step 6. Evaporator absorbs heat from cold room air, refrigerant vaporizes and returns to compressor. Cycle repeats. Compressor, the heart. The compressor is the heart of the refrigeration system. It draws in low-pressure refrigerant vapor from the evaporator and compresses it into high-pressure, high-temperature gas. This compression process is essential for moving heat energy through the system, enabling the continuous refrigeration cycle that keeps your cold room at optimal temperatures. Condenser and fans. The condenser coil receives high-pressure hot refrigerant gas from the compressor. As the gas flows through the condenser tubes, powerful fans blow ambient air across the coils, removing heat from the refrigerant. This heat rejection process transforms the hot gas into a high-pressure liquid, ready for the next stage of the cooling cycle. Hot gas. After compression, the refrigerant becomes high-pressure, high-temperature gas. This hot gas travels through discharge lines from the compressor to the condenser. The elevated pressure and temperature are essential for the heat rejection process that follows, enabling efficient cooling of the cold room. Liquid receiver. The liquid receiver serves as a crucial storage tank in the refrigeration system. After the refrigerant condenses from gas to liquid in the condenser, it flows into this vessel where it is stored under pressure. This component ensures a steady supply of liquid refrigerant is always available for the expansion valve, regardless of varying system loads. The receiver acts as a buffer, maintaining optimal refrigerant flow to the next stage of the cycle. Filter dryer and sight glass. The filter dryer removes moisture, acid, and contaminants from the refrigerant, protecting system components from corrosion and blockages. The sight glass provides a visual window to monitor refrigerant flow and detect moisture presence through color-changing indicators. Together, these components ensure clean, dry refrigerant circulates through the system for optimal performance and longevity. Expansion valve. The thermostatic expansion valve, TXV, is a critical metering device that regulates refrigerant flow into the evaporator. It creates a significant pressure drop, converting high-pressure liquid refrigerant into a low-pressure mixture. The TXV precisely controls the amount of refrigerant entering the evaporator based on cooling demand, ensuring optimal system efficiency. Evaporator, inside cold room, heat absorption and refrigerant vapor return. The evaporator is mounted inside the cold room where it absorbs heat from the surrounding air. As warm air passes over the cold evaporator coils, the liquid refrigerant inside absorbs this heat and evaporates into a low-pressure vapor. This cooled air is then circulated back into the cold room, maintaining the desired temperature. Complete cycle. Vapor returns to compressor, cycle repeats. The refrigeration cycle operates continuously to maintain cold room temperatures. After absorbing heat in the evaporator, refrigerant vapor returns to the compressor where it is compressed and sent through the condenser, liquid receiver, filter dryer, and expansion valve before returning to the evaporator. This endless loop ensures consistent cooling performance. All parts work together. The compressor drives the entire system, compressing low-pressure vapor into high-pressure gas that flows through the condenser for heat rejection. Liquid refrigerant passes through the filter dryer and expansion valve, precisely controlling flow to the evaporator for optimal cooling performance. The evaporator absorbs heat from the cold room, returning vapor to the compressor to complete the continuous refrigeration cycle. Reliable performance, energy efficient, built to last. Key components: compressor, system heart, condenser and fans, heat rejection, liquid receiver, refrigerant storage, filter dryer, moisture removal, expansion valve, pressure control, evaporator, cold room cooling. High efficiency, reliable performance, energy saving, long lasting. Thank you for watching.